Chapter 3. As I remind you, I just want to let you know that Chapter 2 and Chapter 3 are the same test. So Chapter 2, we were dealing with velocity, and now we're kind of dealing with what calculus people would call the derivative of velocity, which would be acceleration. So what is acceleration? It's a non-uniform change in motion. So that means our velocity is always changing. You can be accelerating or deaccelerating. If you're accelerating, that means obviously your velocity is getting faster, quicker and quicker and quicker. And if you are deaccelerating, that means you're slowing down slower and slower and slower. So you can have deacceleration or acceleration. And since acceleration, you can slow down, you can have a negative value. Also, just like velocity, acceleration needs to have a direction. So keep that in mind. So acceleration is a change in velocity. It's non-uniform motion. It's change in velocity at all times. So what we can do is we can one-up ourselves. Instead of having position time graphs like we did for velocity, we can have a velocity time graph where velocity is on the y-axis and time is on the x-axis. And instead of the slope, remember a PT graph, the slope is velocity. For a VT graph, the slope is acceleration. Also, right, the area under the curve or under our graph, under our line on the graph, is equal to our total distance traveled. So there are lots of pieces of information a VT graph tells us. It tells us a little bit more than just a simple PT graph. So as we talked about, acceleration, the rate at which velocity changes. And it can be accelerating or deaccelerating. If we write it as an equation, and remember in 2.4 I said that it might be a good idea to kind of make a note card. Well, here's a big equation. All right. Excuse me. Acceleration is equal to velocity divided by time. Acceleration is A, velocity V, time is T. These constants are never going to change. So in 9 chapters from now, when we're talking about T, little t is time. All right, little v is velocity. Now, what would be the units for acceleration? Well, velocity, we know the units are meters per second divided by time, which is seconds. Well, when you divide things, remember you can always multiply by the reciprocal. So instead, we're going to go meters over seconds times 1 over seconds. And our units for acceleration are always meters per second squared. Meters per second squared is our unit for acceleration. So acceleration, a change in velocity at all times. Now, what we can do is just like we had average velocity and instantaneous velocity or speed, we can have the same for acceleration. So when we look at acceleration, average acceleration is the change in velocity during some measurable time. So you're trying to kind of figure it out a little bit at one particular time on the graph. So if I pick 1 point on my graph, I'm trying to find the average acceleration. Well, the average acceleration would kind of be over 2 points. Which remember, on a VT graph, if I take 2 points, I can just find the slope between the 2 points. If it's a linear line, if it's exponential or power, it's going to be a little more difficult. But if I find the slope, that's going to give me the average acceleration for that line. And the equation for that, this is just a hyphen here, so it's not negative a. It's just acceleration is equal to change in velocity divided by change in time. So pretty much the same equation that we got the last time. Now when we're talking about instantaneous, that's one spot at the graph. Right. Well, how would you figure that out? Well, you're going to draw a line that is tangent to the graph. And what's a tangent line? It's a line that strikes the slope only at one place. So if I drew a circle, right, and my tangent line is going to be a line that strikes it simply the circle at one spot. So that line would be tangent. If I wanted to figure out the slope of that red line, That would be the example. That would be figuring out the acceleration. So if I kind of erase this and do kind of what I could do for real life here, or kind of a better example. This is my graph, and I have acceleration like that. I want to find a tangent point right here, which would be just like that. The slope of that red line would be my instantaneous acceleration at that point. So keep that in mind. So we're going to do a couple math problems with the acceleration, and you're going to have to read some VT charts. All right. So as I just explained there, you're finding it using a tangent line, and more importantly, just like velocity, acceleration is a vector quantity. So that means acceleration has it has a unit and a direction. So acceleration and velocity are the same in regard to they are vector quantities. They have acceleration and velocity. So we will talk more about this in class tomorrow. We'll do some problems and we'll work on VT graphs on top of our PT graphs.